In this section, we're going to deal with linear inequalities. Just a little refresher. Remember that if it's strictly greater than or less than, that means the number is not included. And when you see that on the number line, it has an open circle. If you have greater than or equal to or less than or equal to, it's going to have a closed circle to show that that number is included. So if we're going to graph this number or this inequality on the number line, we're going to say x is greater than or equal to 4 because it's colored in on the 4 and going to everything greater than, so up to infinity. So that's as an inequality. Set builder notation is just a fancier way of writing an inequality. You've got a bracket, and then you'll say x such that, the long line stands for such that, and then you just have x is greater than or equal to 4. So you basically rewrite the inequality. So it's just a fancier way of writing an inequality. Interval notation is where you use parentheses or brackets. Remember, you use parentheses if it's not included. So if it has an open circle, you'll use brackets around it if it's got a closed circle or is included, a greater than or equal to or less than or equal to. So on this one, since we're including 4, it's going to have a bracket on 4, and then it goes to infinity. And then on infinity, you're going to have a parentheses because you can never actually reach infinity. So whenever you're going to positive or negative infinity, it'll use a parentheses, never a bracket, because you can never include infinity. So let's look at this example. It says, write the interval expressing all real numbers less than or equal to -1 or greater than or equal to 1. So let's just mark our number line. We'll do a 1 and a -1. The first part says less than or equal to -1. So we're going to have a closed circle and everything less than that. And then the next part says or greater than or equal to 1. So again, we're going to have a closed circle and everything greater than. So if I'm writing that in interval notation, the less than or equal to -1 is going to be from negative infinity up to -1 with a bracket, or 1 to infinity. And instead of writing or for interval notation, you're going to use a union, which is looks like a capital U without the tail. So in interval notation, putting it together, it's negative infinity to -1, unioned with 1 to infinity. So that would be your answer in interval notation. Okay, let's look at some properties of inequalities. If you have A is greater than B, where A and B are any numbers, then if you add anything to A, so let's say A plus C, that's going to be greater than, or sorry, that's going to be greater than B plus C. So it maintains its inequality if you add the same thing to both sides. And works the same way if you're subtracting, or if it was A is less than B, then if you added the same thing, the A plus C would be less than B plus C. So that basically, what that does for us, it lets us work out these inequalities just like we do algebraically with an equation. So here, if I have 6 is greater than or equal to x minus 1, I can add 1 to both sides, just like I would do if that was an equation and I'm trying to get x by itself, and I'd end up with 7 is greater than or equal to x. Or if you want to flip that around, x is less than or equal to 7. So that's the inequality. If you want to write that in interval notation, drawing the number line really helps to visualize it. So I'm saying x is less than or equal to 7. So it's everything to negative infinity up to 7 and including it. So you're going to have a bracket on 7, but not on the negative infinity. So this is your answer as an inequality. And this is your answer in interval notation. The other property is the multiplication or division property, and it says if A is less than B and C is greater than 0, so C is a positive number, then if you multiply A times C, that's going to remain less than B times C. However, if A is less than B and C is less than 0, so C is a negative number, it's going to switch your inequality sign. So instead of being less than, it's going to change it to greater than. So basically what you need to remember is if you multiply or divide by a negative, then you need to flip the inequality sign. Every time. So if you multiply or divide by a negative, make sure you switch the inequality sign around to face the other way. So let's look at this example. If I was going to work this, I would add 1 to both sides, which would give me negative 2x is greater than or equal to 6. And then I'm going to divide by a negative 2. So when I do that, that'll give me x. And then I need to flip that sign from greater than or equal to less than or equal to. And 6 divided by negative 2 is going to be negative 3. So we've switched this sign around because we divided by a negative number. So don't forget that when you're working that out. So that's your answer as an inequality. If you were going to write it as an interval, again, you can draw your number line, and we have x is less than or equal to negative 3, so that's going to be negative infinity to negative 3 and including it because it's or equal to. So just depending on the homework question will depend on what form they want your answer in. Okay, same thing on this one. I will tell you, if you look at your x terms and move the smallest one, it will avoid having to multiply or divide by a negative number. So if I choose the negative 2x, or if I move the 2x, which means I would subtract it from both sides, I'm not going to have to divide by a negative number. So here I'm going to subtract 7 from both sides. You can subtract, but if you would divide, I would have had to switch it. So now here I'm just dividing by a positive 2, so my inequality stays the same. And I end up with x is greater than or equal to negative 5. if I'd have chosen to move this instead of the 2, I would have had to divide by a negative. So if you choose to move the smallest x, if you do that, you'll avoid dividing by a negative. And then again, if we were going to write this as an interval, that's x is greater than or equal to -5. So we're going to have a bracket on -5, and it's going to infinity. So that's our answer in interval notation. On the next example, same concept, but I'm going to get rid of this fraction by multiplying everything by the denominator. So I'm going to multiply both sides by 2. And when you do that, it'll clear out the fraction. So I'll have negative 2x plus 8 is less than, when I do 2 times 1/2, those will cancel each other out. And it'll just leave me with x plus, but remember you also have to multiply the 1 by 2. So don't forget that. Make sure everything gets multiplied by 2. So now I have just a regular inequality that I can solve like I did the 2 previous examples. I'm going to add 2x to both sides. So I've got 8 is less than 3x plus 2. Then I'm going to subtract 2 to get my x by itself. So I've got 6 is less than 3x. And then I'm going to divide by 3. So work these out just like you would a regular equation. Just be careful of keeping your inequality sign the same. So I end up with 2 is less than x. Or if you want to rewrite that with your x first, you have x is greater than 2. And then that in interval notation would be a parentheses on 2 to infinity. And the parentheses because you have greater than. Okay, on this next one, again, we've got some fractions to deal with. So figure out what your least common denominator is. What do 4, 8, and 3 all go into? And that's going to be 24. So our least common denominator is going to be 24. So just so I can get rid of all of these fractions, I'm going to multiply everything by 24. So let me bring that down here. If I do 24 over 1 times -3/4 x is greater than or equal to 24 over 1 times -5/8 plus 24 over 1 times 2/3 x. So that looks like a mess, but what's going to happen is when I multiply these first two together, my 24 and 4 will reduce so that I'm left with 4 goes into 24 6 times. So I can divide those both by 4, and that leaves me with 6 and 1. So when I multiply this together, I do top times top, which is -18, and bottom times bottom would just be 1. So just leave it as -18x. Same thing here. My 8 and my 24 will reduce to 3 and 1. So I'm going to have 3 times -5 is -15 over 1 again. And then my 3 and my 24 will reduce to 8 and 1. So I've got 16 over 1, so 16x. So by multiplying by the least common denominator, it clears out all the fractions. So you can just have a nice, neat inequality to deal with. So here I'm going to subtract 16x from both sides, which will give me negative 34x is greater than or equal to negative 15. Now here I'm going to end up dividing by a negative. So when you do that, make sure you flip the inequality sign. So instead of greater than or equal to, I'm flipping it. And then my negative divided by a negative gives me a positive. So I'll have 15 over 34. So a couple things. Make sure you flip your sign because of the negatives. And then when you have a negative divided by a negative, it becomes a positive. So that is your answer. 15 over 34 won't reduce, so just leave it like that. Or if you're asked to put it in interval notation, you have x is less than or equal to, so that's going to be negative infinity up to 15 over 34. And you'll have a bracket on that because it's or equal to. So that's that written in interval notation. So if you have fractions, see if you can get rid of them by multiplying by the least common denominator. Next we have compound inequalities, which just means we've got two or more inequalities, usually only two. But you're going to deal with this the same way. It's just whatever you do to one side, you do to all sides. So if I'm going to subtract 2, I'm going to subtract it from every part of the equation. Because really I've got two different inequalities put together here. So that's going to leave me with 1 less than or equal to 2x less than 4. And then I'm going to divide by 2, but I'm going to divide everything by 2. So that leaves me 1/2 is less than or equal to x is less than 2. So that's my answer as an inequality. Now here a number line really helps because there's two parts to it. So if I've got, let's say I've got 0 here. This first part says x is greater than or equal to 1/2. If I graph that part, 1/2 is about right here. I'm going to have all of this. So that's that part. The other part is x is less than 2. Well, if I graph that, I don't include 2, and that's everything that way. Well, both of those have to be true. So the part of the number line that is true for both is where they overlap. So this highlighted region is where they overlap. So when you write it as an interval notation, it's going to be 1/2 to 2. A bracket on 1/2 because it's got the or equals, and a parentheses on 2 because it's just strictly less than. So that would be your answer in interval notation. And I strongly suggest you draw the number line so you can see that when you have to write it in interval notation. Now this next one, it's a little more complicated because it has an x term in each part. So what you're going to want to do here is write two inequalities and solve them. So I'm going to have 3 plus x is greater than 7x minus 2. That'll be that first part. And then the other part will be 7x minus 2 is greater than 5x minus 10. So I'm breaking this into two equations, or two inequalities. But then after that, you just solve them like we have been. I'm going to move my smallest x. And then add 2 to both sides. So I've got 5 is greater than 6x, and divide by 6. So I end up with x less than 5, 6. And you can flip that around. And then the other part, you do the same thing. I'm going to move my 5x. So that'll give me 2x minus 2 is greater than negative 10. Add 2 to both sides. So I've got 2x is greater than negative 8, and then divide by 2. And that'll give you x is greater than negative 4. So we've got 2 parts of this, and they both have to be true. So again, this helps if you graph this on the number line. So I've got 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Five, 6 is almost up to 1, so I'm going to put an open circle there, and its x is less than that. And then the other one is x is greater than, so again, an open circle. So everywhere they overlap, and this one's continuing on, so the overlap is your interval. So all of this shaded area is where they would overlap. So my inequality would be a parentheses, my interval would be a parentheses on negative 4 to 5, 6 with another parentheses. And that is because they're all both strictly less than or greater than, no equal to. Okay, the last example involves an absolute value inequality. And what we're going to do here is turn this into a compound inequality. And the reason for that is because recall that absolute value is the distance from one number to another, which means from the right and the left. So we're going to be coming from the positive direction and the negative direction. So when you write an absolute value as a compound inequality, or if you're asked to solve one, you're going to have the regular way that it has, x at minus 1 is less than or equal to 3, but you're also going to have coming from the negative direction. So you want to squeeze it between the positive and the negative value. And then once you've done that, you're going to solve it just like we did before. I'm going to add 1 to both sides. And I've got negative 2 is less than or equal to x is less than or equal to 4. Or if you want to read it from the x, you can say x is greater than or equal to negative 2 and x is less than or equal to 4. So if you graph that, got x is greater than or equal to negative 2, so it's going this way, and then less than or equal to 4, so it's going that way. So where it overlaps is your interval. And we're going to use brackets on this one because it's got the or equals to. So that is the end of this section. Hopefully that will help you get through all the practice problems.